Okay, welcome all. The first thing that I want to do in today's class is introduce our class, the theory lecture TA to you. He'll be present throughout our lectures, and his name is Kaushal. He's a final year BTech student here. He's actually a dual degree student. So Kaushal, please take a minute, introduce yourself. If you can switch on your video, that will also be very good.
Actually, there's a problem with my webcam, so I'll
Okay,
just
never mind. You can just introduce yourself. Yes.
hello everyone. I'm Kaushal. I'm a final year computer science dual degree student. Yeah, I'm working under Deepak Imani sir. So I hope I have a good time with you guys. I hope I'll learn with more with you guys. Yeah.
Okay. So Kaushal is the go-to guy in case you find any issues with okay, the lectures are not available, the slides are not available. You should ping him or of course me, but we'll get it done via him, and I'll also take care of updating the homepage. So as you must have seen yesterday evening, I have sent you the link to the homepage. So you will be seeing the lecture slides as well as the recordings and on that homepage. Okay, so let's get started with today's part. So what we did in yesterday's class was that yesterday's two classes was that we programmed our friend Vidushi. We asked her to do certain tasks for us. We'll call this the exercise that we did as programming. Then we programmed the turtle and we drew some interesting patterns. In fact, I do hope that many of you explore the turtle and draw interesting patterns, send them to me if possible, and show them to your TA, show them to your friends. And then we also saw what is text only turtle. So that is it allowed us to print some simple patterns that we started with initially. It also allowed us to print some characters and so on. So this is what we did in day one. What we want to do today is move from the turtle programming to our C programming language, which we said that is the intent of the course. We want to learn the C programming language and use a C trained computer. For that, we need to write a program in C, that is edit a program, compile it and execute it. We want to understand the meaning of all these terms. Yesterday, we just used them as a black box and we did not care about what is happening inside. We also want to understand the basic structure of a C program. While it will be a very, very simple program that we will write, we still have many things to understand. And then we will also go to introducing the platform that you will be using throughout the course, which is called REPL.IT. And this is something that you will be using throughout the course. You can of course use your laptops to do things locally for your checking, your testing, your understanding. But when you are submitting assignments, you are going to do it on this platform, which we will introduce to you, and then we will use that during the labs throughout the course. Okay, so whenever we want to write a program, we should ask ourselves, what do we want our program to achieve, right? So we need to set out a clear set of tasks. Only then we can make sure that our program is correctly written, it is doing what we desire. Therefore, we need to understand what do we want our program to achieve. Of course, we can we may be very ambitious and we can ask very ambitious questions, but at the moment we do not know the language. Therefore, we cannot ask too many things. We are going to ask very modest things. So whatever we asked Vidushi to do yesterday, or whatever we asked our turtle to do yesterday in the second part of the class, we will ask our C program to do it. That is print this pattern. It seems repetitive and slightly boring, but so haven't we done it already? Yes, we have done it, but we haven't done it in C, and we have not done it on the platform that we want to use. So think of it like this, that you want to bake a cake. You have already baked it in some fancy tool, which is very easy because somebody set everything for you. You just had to turn the knobs. Now you are going to do everything by yourself, adjust the knobs, understand the meaning, of course not design an oven, but understand the knobs and so on, and then bake the cake, right? So this is a very, very crude analogy to this, but we are going to now print these patterns by when we write the program, compile the program, and execute the program, and go slow for each of these steps, understand each of these steps. Okay, so the next question is, what do I need to know to achieve writing this program in C? So since this program is only printing some strings or characters, the only thing that you need to know is how to give a command which prints something in C. So that is the command for printing in C, and that is what we will learn. But we will also need to learn how to put this command together. What is the structure of the C program, and that is what we are going to see throughout this lecture, and also execute that program. Okay, so this is your first C program. Again, if you are seeing it for the first time, there are many new things. If you are seeing it you have already seen it, then you know some things, but we are going to dissect each and every line of it and understand it. So what is the difference between yesterday and today? Yesterday we said ignore these lines. Today we are not going to ignore these lines. We are going to give a description of them to some extent, to the extent that we can explain with the current knowledge that we have. Okay, so if you see this, the C program has a include stdio.h. So this stdio.h is a file, which is a library file, which is present somewhere on your computer, which we are calling a C-trained computer. I will come to what is a C-trained computer, but it is present somewhere on your computer or the platform that you are going to use. This has useful functions that we will be using, and therefore it is important for us to include this file to tell our program that these useful functions are available to our program. So this is the first line which all our C programs are going to contain. This is include stdio.h. There is a particular thing which is hash include. I will wait to tell about that a little later, not in today's class. Then the next line is int main. So this main is something which is a keyword, that is you cannot change this word. You must write this in this main itself, and these parentheses tell that this is what is called as a function in C, and this function does not take any parameters. So that is why there is something which is empty. Connect it with your repeat, which took a parameter which is an integer k, or forward, which took a parameter which is the number of pixels, and so on. So what is this int doing here? This int is saying that it is a return type of main. Again, why should it have a return type? That is something for the way the C programming language has been designed. We will again come to it a little later, but this is the return type of this function, which is an integer. So that is what it is telling. This is also a keyword, which is int. So these things cannot be changed. Int main, these cannot be changed. These two parentheses which are there, the curly braces, are some things which tell that what is the body of the main. So whatever is inside here is the body of the main program, and that is what is of interest to us. So whenever you write a C program, you are going to write include stdio.h int main with these parentheses, and this returns 0 for the moment, which tells that we are returning nothing, returning 0 from this program. Who is going to accept it and something is, we will come to it slowly. So again, bear with me that we are going to write these lines in our program. They do mean something, but we'll come to them slowly. So the only relevant part of the code which is for printing the pattern are these 4 lines, which are printf with these asterisks, 8 asterisks and a slash n there. So the number of lines that I have to write depends on the number of rows of the rows in that pattern. So I have 4 rows, therefore I have written 4 printf statements. And the printf is, again, think of it like a cout or some command that you have to understand or you have to know to be able to communicate to a C trained computer. So the print is very natural. It says print it to the output. The F stands for formatted output. We'll come to what is formatted output when we define integers or the different variables, and then how do we want to print them to the screen. So this is what is our basic C program. The printf will have printf will take a parameter which is at the moment we are just going to print out strings. So therefore we'll put them in double quotes. Wherever we want a /n, we are going to put a /n appropriately as I have put in here. And then each statement has to be terminated by a semicolon, the way I have done it here. This semicolon is also important. The C programming language expects this semicolon at the correct places. So you see that this program has 5 different statements. The 4 are printf, the last is a return 0. Return is also a keyword that is that is specific to this. So the only things that possibly you can change in this program if you want to print something else is printing a different set of strings here where I have put in the asterisk. Okay, so this is what I have described to you as the first C program. I would stop here and ask if there are any questions. I also see that there are some chat messages that some people have put in. Yeah, so I look at those chat messages. In the meantime, you can also unmute yourself and ask questions. Okay, so one of the questions from Matthew is that inside, if we write int main, inside that if we write void, that also works. Yes, that also works, and that also says that it doesn't take in any parameters. So at the moment we are not using that, but it does work. Okay, so can we have void main? We will try that and we'll see what happens when you do the return type of that is void. We'll see what happens there. So that is a good question. Then,
ma'am, like it's given that main a function that every C program must have. So is it necessary to write int main, or is it just okay if we write only main?
Okay, so we'll see what happens when we go to our platform and check out what what happens. Different compilers may behave differently. Some compilers may give a warning. Some compilers may not allow you. So we'll see what our compiler does, right? But
Okay.
the return type of that, we are telling that it's int main, right? Okay. Okay. Yes. Can't we use void main? I'll come to that. Okay, so there was one question which was asking, yeah, does int stand for integer? Yes, int does stand for integer. Is return 0 necessary? Again, different compilers will behave differently. It will say that even if you have said int main, you are not returning something, it may stop with a warning. We'll see what our compiler does, right? So we'll see that. Do cout and printf do the same job? Yes, cout and printf do the same job at a very high level, but again, the way you operate them is slightly different. So we have to learn how printf operates because we are going to learn the C language. So at a high level, yes, they are used to print things to the output. The way you have to use them is different. I will not go into the differences right away because we have not dissected cout also. Neither we have learned how to use printf in the most general way. So I will not be able to dissect that. There are differences, but at a high level, yes, they do print out things to the output. Okay. We are giving int instead of void because we are returning a value. Yes, we can do, okay, so we can have void main, we can have int, I mean, we can change that. We will come to these things, that is, because we have returned a value, are we writing it? Yes, so we'll come to it in a minute. Is that okay? The one more question that I have is, okay, there was one question that somebody had asked is, will repeat work in this? In fact, no, and we will see that we will not be able to use repeat or see out in a C trained computer. So we will not be able to use them. If we write, so the one of the questions is, if we write string main instead of int main, will it work? No, C does not understand a data type called string. I have not even said what is a data type, but it does not understand what is a string. So we cannot write string main. So it will not work. It will not understand it. Okay, so is there any preference of integer type main over void main? Okay, so so there is no preference of integer. I mean, there is no preference. I will also come to it where this int main is useful. So remember that it is a function. So if it is a function, it must be called by somebody. So there is somebody who is going to call it. If you want that, somebody should know what is the return, or what, how did this program execute? Did this program execute correctly? If it executed correctly, I am going to return a 0. If it did not execute correctly, I am going to return a -1. Then I can give the appropriate return value. In which case, typically these programs have a return value also, and therefore you can return it to the calling environment. How does one get it? We don't have the tools to say it right now. We will say it as we go along the course. So there is no preference at the moment. Nobody is catching the return value, so you can write void main also. Okay. Okay. So one of the questions that is there is, what is the main difference between C and C++, right? Okay, so C and C++ are designed philosophically in a very different way. C is a procedural programming language, whereas C++ is an object-oriented programming language. So it expects you to think about these things in a different way. An object-oriented programming language deals with objects, and then you want to write these functions for these objects which are defined. For example, yeah, so instead of printing these messages, we would have defined a message class in C++. Again, people who have not seen C++ may the concept of class may be slightly new, but we would have thought about it in a different way if we would have written C++. So C++ is a different way of thinking, or an object-oriented programming is a different way of thinking about writing programs. We are not going to go to C++ for the object-oriented part in this course. So C is a procedural programming language. We want to do this. We are going to learn a set of commands and achieve those during the course. Okay. Yes, so if we are using int main, we are going to be having the return value as only integer. Again, if you return something else, the compiler will do something for you. We can try all those things out. Okay, so I have taken whatever are there on chat. Does anybody have any other questions or comments? Most of them, I think. I mean, some I may have. Some of them were repetitions, or I don't know if I have missed anything. Okay, so so this is what is the first C program that we have written. typically one writes hello world. This is no different from hello world, except that we are saying that we are printing the same patterns, that pattern that we had asked Vidushi to print. We have asked our turtle trained computer to print. Okay, good. So to do anything more than printing just to the screen, we need to have more operations. That is, we need to know a little more about the language, and we need to store. We need to have storage for temporary computations, and that for that we need to define variables. So we are going to come to it. Not today, but very soon in the next week in the first class, we'll come to defining variables and so on, which will allow us to do many more meaningful things than we are doing now. So at the moment, we'll have to live with just printing some things to the output. Okay, so I am going to run this program on the platform that we have. But before that, I want you to absorb a few things about what is happening when we write this program and run it on the machine that we are going to use, or the platform that we are going to use. So whatever are these programming languages, C, Turtle, and C++, these are what we call as high-level programming languages. That is, while they have a certain set of commands, we cannot talk in English to the computer. It is almost English, or it is not almost, but quite close to English, and it is very much understandable to a human. On the other hand, computers do not understand this language. So whenever we have used this term yesterday, a turtle trained computer, C trained computer, this is abuse. It is just for the sake of convenience. A computer really does not understand the turtle language or the C language or C++ or Java. The computer only understands binary. It understands 0 and 1. So there must be something which is going to convert a high level program, which is our program that we showed on the previous slide like this, to something that the computer understands. And this is the task of what is called as a compiler. A compiler is again a program which is written in a programming language, and it is a useful tool to convert a high level program to something which the computer understands, which is a binary, and which is an executable for the computer. Does the same executable work on different machines? No. If you have to execute it on at least for the context of C, you have to execute it on this machine, which is my machine. I have to compile it on this machine. If Kaushal has to do it on his machine, he has to compile that program on his machine, generate an executable, which is going to be a binary, and then run that executable, or make the computer execute those set of commands, which will finally give you the output of the program, which hopefully should be your desired output, right? So this is what is a compiler, and a compiler is what we will be using. So you have possibly already used it. GCC is a compiler for C programs. Simple CPP, or those that IDE that I was showing you yesterday, had a compiler which is Simple CPP or S++ on the Linux machines, which is a compiler for using Turtle or compiling Turtle programs. You may have used G++, which is a compiler for C++ programs, and so on. So this is what is a compiler, which is a tool which will take a high level program and convert it into something which the machine understands, which is an executable. So whenever we say a C trained computer or a Turtle trained computer, the only thing that we mean is that it has a compiler for that programming language, or those high level constructs, and it can take those constructs and somehow convert them into code which the machine understands. Okay, so are there any questions about this? Yeah, so Raghav has this question: can we use VS Code? I don't understand what is VS Code. Okay, okay. So before I go to another question, so are you Virtual Studio Code. So I don't know what is Virtual Studio Code. Okay, so you can have different IDs or different platforms where you are going to code. Internally, there will be some compiler which is going to compile it and convert it into a program that the machine understands. That's all I'm saying. Okay. In VS Code, we can use different extensions of different languages which compiles them. Yeah, possibly. I'm not familiar with this Virtual Studio Code and those things, but yes, you can have, you possibly it understands the different extensions. I'm not aware of that, so I will not be able to comment. Do different compilers have different syntax? So do you mean that for a same language? Is that the question? So okay. So no, for the same language. So if you have different compilers having different syntax, it is going to be very difficult because then you cannot take your high level program and compile it using different compilers for the same language. So there is a standard that people develop. So GCC is a standard. The only thing when I said that different compilers will behave differently is on the level of the strictness. Sometimes some compilers are a little okay with some of the things that are unacceptable. They will only leave you with a warning. Some compilers will be very strict and they will not allow you to do some of the things. Some of the things are completely forbidden in all the compilers of the same language. Some of them may vary depending on the degree of the strictness of the compiler, but the syntax doesn't change. Okay. So the computers convert everything to binary before executing the code. Yes, they will convert everything to binary, which is called as the binary executable or an executable, which is a binary. I'll show you that when we go to the platform. Okay, so can the same code be used in GCC and simple CPP? Okay, so yeah, so I think simple CPP will support a printf statement, so you should be able to use that. But this stdio.h will be something that will not be allowed in the simple CPP. I have not tried that, but you will have to use something which is specific to the C++ programming language. So therefore, exactly the same code won't work. Is my this thing. The same code will not be compilable using GCC and simple CPP. You will have to change some minor things. And of course, simple CPP code will not work in GCC because a C compiler does not understand turtle. It does not understand cout. It does not understand these things. Okay, very good question. So one of the students has asked, if it understands binary, why don't we directly enter stuff in binary? Excellent. So now I'll let the class to answer this question. So the computer does understand binary. Why do we write it in the high level programming language? Yeah, I don't, it's not, maybe it is interesting for some of you to unmute and.
Hello, ma'am. Ma'am, we don't type in binary because we want to make our work easier. Like it will be very tough for us to write codes in binary.
Okay. So to convert a very small program into binary, it will take a very, I mean, even to convert the basic program just to print maybe a character on the screen, it will take a lot of work for us to give it the message, give the same set of instructions to the computer in binary. And therefore, it is going to be a very tedious job and also a very error prone job. To convert it into to write a program in binary. Therefore, we just to make our life simple, we avoid writing in binary. But there are low level programming languages like assembly language and so on, which are even at a lower level than the high level programming languages. And those allow you to write code which is closer to what the computer understands, move, add, and so on. There are very few set of commands available, but then you can use them to write all the programs that you want to write. but it becomes a very tedious job. So in fact, what we want to do is we want to move to a level where we can talk to a computer and give it commands and it understands it. The question is in the other way. Yes, why don't we give it commands in binary? Because it's very tedious. So therefore, people write compilers. People write compilers for as high level programming languages as possible. Okay, so I hope it answers your question. Okay, any other question on this part? Okay, so a few things that we want to remember while we are writing programs is the computer is very rigid about rules and syntax. So what do I mean by computer? It's not the computer, it's the compiler is very, so I should use the word compiler. A compiler is very rigid about the rules and the syntax. So it cannot be, you cannot mess around with it. You cannot say, okay, I just forgot a semicolon, just take care of it. That it will not allow you to do that. So you will invariably see compile time errors or warnings. So we'll try to do that. We'll remove a semicolon, we'll remove int from int before the main and so on. But however, it is accommodative of some of the things. For example, you can put in spaces as you like. And in fact, this can lead to bad things, which is called as unindented code, which we should avoid writing. We should always try to write code which is what is called as indented or readable by any other person, your friend, your TA, your instructor, or you yourself after a few weeks or something. If you write code which is completely haphazard in terms of indentation, it will lead to difficulties when you are trying to go back to it. So these are some things that we need to remember about when we are writing a program. Having said this, I want to go now to the platform, show you how to use that platform to run the program, and also possibly show you a few things which are specifically related to the platform and the compiler, etc. So before I switch to the platform, are there questions? Okay. Okay, so Kaushal, I would like you to tell me whether you can see my thing after a while. I'm going to stop sharing my slides and I'm going to share my browser. Okay. Okay, so what you see hopefully on the screen is, let me just give me a minute. Yeah, so I hope all of you can see something which on the browser which is called repl.it. Kaushal, can you confirm that you are able to see this repl.it?
Yes, ma'am.
Okay, so this repl.it is nothing but a platform which will allow you to get almost the same interface that we would have liked to have in our labs if you were here in person. So all of you are going to create a repl.it account. Not now. Please avoid the temptation of going to the internet and creating it because it will be helpful to pay attention to what I am telling you right now. So as soon as you create an account, you will see the same view that I am seeing. And if you go to my repls, it is these are some repls. You don't have to worry about these folders that I have. They are created for our labs. I am going to say that I want to create a new repl. So somehow, yeah. So this, on the left hand side of the screen, there is something called as a new REPL. I'm going to click that and it tells me what programming language I should choose. You are not going to create a new REPL. You are going to be added to a team because we want you to work in a particular environment, but you can do this for your own testing. This is, I'm going to choose the C programming language because I'm going to use the C programming language, and I'm just going to call it CS1100 class 3 because it is our third lecture, and I'm just going to say create REPL. So this is going to create something which it will show up on the screen, and it is very similar to what I have shown you in the program. So it already gives me a template of a simple C program in Cprogram in this platform. So this, the name of this C program is main.c. So it is typical to give the extension as .c, main.c, which is the C program. It again has this include stdio.h int main, and as some of you had pointed, it has this void, and it has the same structure that we had shown here, except that it is customary to write the first program which will have hello world. So this is what it gives me as a template for the first program. So this program is pre-written for you as soon as you do a new REPL. You can try this out in the lab when we meet in the afternoon, but this is what it will show you. Okay, so any questions or any comments on this part that I have shown you till now? Okay, so on the left hand side, what you see is an editor, which is here. On the right hand side, where you see there is a console, you will be able to do things which will simulate what is your environment on a Linux machine. And typically when we hold our labs in CS1100 in person here, we have all our Linux machines. So this is very close to what you would have seen in the lab. So the first thing that I'm going to show, I'm going to show is a command which says ls, which is a command in Linux to list what is there in this current directory. So in this current directory, there is only a file which is main.c, which is which is going to be visible here. So, okay. So I want to ask one thing, Kaushal, are you able to see messages that I get, or no, the chat messages?
Some of them I can't see, ma'am, since some are sending you in private, I guess.
Okay, so so I don't know some of the message. So for example, so one of the students says what I couldn't join the. Okay, so so if you have joined late, don't worry, I will get back to you. I'll not interrupt myself in this class for the few minutes now. So the first command that is there is ls. You don't have to worry and remember anything, but this command is ls, which is listing out what is there in the current directory. There is only this main.c, which is this file, and this file, this C program is going to print out hello world. There is also a helpful run button here, which I am not going to use at the moment, but I'm going to show you how to compile this program. We have talked about compilers. So I'm going to use this compiler, which is GCC, and I'll say GCC main.c, which will compile this program. If your program is correctly written, it will compile quietly, not tell you anything. But if you do ls, you will see two files now, one which is a.out and the second which is main. The a.out is the binary executable of the program, which is main.c. Why is it called a.out? Again, it is customary, and it is this is how it has been done. So it will always, if you don't tell what is the name of the output, it will always output it as a.out. How do you execute this? You are going to say ./a.out, and this is going to be something which will print this execute this program. And since this program prints hello world, it is going to print out hello world for you. So what did we do? In the first part, it had already written a program for us. if we want to write something else, that is print out the asterisk, we are going to change this part of the program, which is let's say I will change it to star, 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 whatever, how many, I have not counted them. But if I now hope that, okay, just because I have changed it in the editor, if I print a dot out, if I execute a dot out, it will print out that. No, this is not how it works. You have to compile the program again, because you have to, the executable is still the old executable. This is just the program that has been changed. The high level program has changed. If you want the a dot out to change, you have to again say gcc a dot out. GCC, I'm very sorry, GCC main.c, and it will create an a dot out, which now if you execute is ./a dot out, which will print the asterisk, right? So I repeat, we have the first thing, which is edit a program, which you will do on this left hand side. If you want to compile a program, you can use the GCC compiler, which you can use it on this right hand side of the panel, which shows console, and you can say GCC main.c, then it will produce an a dot out. And this, if you want to execute the program, then you can type ./a dot out, and it will start executing the program. The execution will do whatever you have given the commands in the program. Okay, so I will also tell you that there is an easier way which combines this compilation and execution together. And if you just press the run button, it will do both the things, that is compile it and execute it. But the compiler is slightly different. That is why I did not use it immediately. It is a different compiler, which is Clang 7. What is -pthreads? -pthread is a library that it is including. -lm is also a library that it is linking. And what is -o? It is telling that the output of this should not be in a dot out, which is the default, but it should be in a file, in an executable file, which is called main. And that is why it is giving that as the parameter. And then finally it is saying that compile the program, which is called main.c. So this is how it works. And therefore, when it executes the program, it is doing ./main instead of saying ./a dot out. So this is how you are going to execute programs in your lab by either pressing the run button once you have created this, or you can also use GCC -o main, or you can also call it differently, my output. This my output will be the name of the executable, but the input is main.c. That is, the main.c is going to get compiled, and the output can be anything else. Let's say my output. And then if you do ls, you will see that there are actually now 3 executables. One is my output, one is main, and the other is a dot out. And the C source code is main.c. So I'll stop here at the moment. I'll pause here and ask if there are questions about this platform or whatever we have done here.
The first line, like the very first line you wrote, could you kindly repeat like what you did, like the ls?
ls, okay. So ls is a short form for list, okay, in Unix. So it is just saying list what is there in your current directory. Okay, so it is going to list out. So just like on a Windows machine, you can click on a directory and folder and see what are the contents of that directory. It is just a terminal way. This is called a terminal or a console in the Unix language. On that, you can give commands to check out what is there in the directory. ls is something which will list out the contents of that directory. Is that clear?
Yeah, okay. Thank you.
Yes. Yeah. Okay. Yes. Yes.
What is the shell in that? Like there is a console and there is shell. What is that shell?
Yeah. So so there are 2 different things in a Unix environment. So so I don't know exactly what is the difference with respect to this REPL. I think the shell is what we see in the Linux shell. Are you familiar with Linux?
Like I have a Linux computer at what I'm currently using on
Okay.
Linux.
Okay, so I have not explored this completely. I would expect that the shell allows you to do whatever you are allowed to do on a Linux terminal or a shell. I think the console may have some restricted functionalities. I'm not sure about this.
Okay.
But at the moment, you can use the same command. That is, you can do ls here and you will see the same things. You can do gcc main.c and you should be able to do the same things here. I think it may provide most of the things that Unix provides in the shell. I'm not sure about it in the console. I admit that I have not explored it completely.
Okay.
This is a new platform that we are also using to make sure that students get the same kind of environment that we have it on our labs. Yeah.
When we click more dot, when we click run, like the file that is created, that is main, will not be stored on the files.
Sorry. Can you repeat the question a little slowly in terms of yeah?
When we click run, it forms a file, like it forms main, no, ma'am, like that is not stored in the files that is showed in the leftmost column. Shows files, no, ma'am. Like when you click the run, it shows a minus p thread minus lm minus o main and main.c.
Okay.
That main is not stored, no.
It is stored, right? So so let me just do the following. Rm is a command that you should be very careful, but if you can use it to remove things. So I'm going to remove the executables that we have created. Rm a.out, rm main, not main.c, rm my output. Oh, so you are saying that it is not on the left hand side. Okay, that yeah. Also, you are saying that it is not showing on the left hand side. Is that what you were saying?
Yes, ma'am. Also in ls also it's not showing. I mean ls
It is showing. Okay, it will show. I will just so currently let's look at the output of ls. It is only having main.c. Is that okay? I have deleted all the other files. If I do run, then it does have main and main.c. Do you see that? Yeah, on the left hand side it is not showing. I do not know why it is not showing that. Yeah, there may be some way to get it, but it is there. It is very much there.
Okay, ma'am. Okay.
Yeah. Okay. Any other questions? Okay, so we are already at the end of the class. I will stop the recording. I will look at the chat messages and try to answer as many questions possible. If people have still questions, they can stay back and ask if they are free. I'll be here for at least a few more minutes. Okay, I'm stopping the recording.